going to use the shade so that we can concentrate on one thing at a time. And the first thing I want to say to you about LeChatelier problems is how I'm going to tell you about opposite and same. Opposite is always going to mean that something is going down. For instance, if something's on the left side and I want less of it, I'm going to reduce that. And I'm going to increase the opposite side. And when I say same, I'm going to use an up arrow. And that means it's going to move to the same side. And the first little reaction that we dealt with, and we saw a video on this, which I can't show you because it's on a CD or a DVD, but I can talk about it. This is the reaction of, it's given right here, the nitrogen dioxide. There's two molecules that are going to combine and form dinitrogen tetroxide, N2O4. In this particular reaction, we have something that is heat sensitive. And so what we did was we heated up the reaction mixture. And you'll see under stress right here, the stress is the heat. We added heat. But you'll notice that heat in the reaction is on the right side. And heat acts just like any reactant or product. In this case, heat was a product, but heat could always, not always, but sometimes, heat could be on the left side, not of this equation, but of some other equation. Or I could be this equation, but I write the equation with the N2O4 on the left side instead of on the right side. And I move the NO2s onto the right side of the equation. In other words, I reverse their sides. Then heat goes with it, goes with the N2O4, and it is now on the left side. And now it acts as a reactant. Because anything on the left, the way we write it, it's just the way we write it. If it's written on the left, heat is a reactant. If it's written on the right, heat is a product. In the video, because they had this opposite, they had it as an endothermic reaction. And so heat was on the left, along with the N2O4. So when this guy put these guys into boiling water, the tube in the boiling water was this line right here. So the boiling water is putting heat into the system. That's why heat is up. What does LeChat want to do? Anything he can to reduce the heat. So how does he reduce the heat? Since heat is on the right side, he wants to shift it to the left. Okay? And by shifting it to the left, notice the arrow there for that line that we were talking about is down. And to take the heat away, going to the opposite side is what he wants to do. And that means shift to the left, because left is opposite of the side that heat is on. And conversely, when he did this next one, he took the tubes and he put them into ice water. And when he put the tube into ice water, that takes the heat out of the system. So that's why there's a down arrow there. And when you look at LeChatelier's side, what does he want to do? He wants to make more heat. Well, the only way he can make more heat is to make the reaction go to the same side as the heat is on. And so that means the shift has to be to the right. And that's how that problem works. That's the heat thing. Now, let's go down one more, and let's look at this guy. And for that, you have to open up your textbook to page 574 and look at the reaction. I will show you the reaction briefly here. If you're looking at this video and you're not using our textbook, you would want to have this reaction so you could follow my discussion. This is the reaction that we're going to use, this line right here, and this will show you the reaction that is being used for both 11A and 11B. And I think we'll just go ahead and leave it up there at the risk of making everything a little bit confusing looking, because I want to be able to see the equation along with it. So let's deal with this guy first. And in this particular situation, The problem states that we're going to take out hydrogen. We're going to remove it from the system. That is the stress. That's why you see the H here with the arrow going down. Now, if I go back to the LeChatelier side, LeChat wants to do the opposite. And so he's going to have an up arrow of hydrogen. And the way he can do that is like we said at the top, arrow up means it's on the same side. Which side is the hydrogen on? We look at it right here, down at the bottom, and we see that hydrogen is on the left, and so the same side is shifting to the left, and that's a left shift. Now, on the next problem, we're increasing the amount of ammonia. That's actually putting more of the ammonia gas into the reaction vessel. And LeChat, of course, wants to take it out. And the only way he can take it out is going to the opposite side. And we see ammonia's on the right. The opposite side is the left. And so this is also a shift left, because the stress was different. Okay, here the stress was with the ammonia. The one before, the stress was with the hydrogen. And now we go a little bit further and we look at the last problem, and let's get this out of the way so we don't have to look at that. We can just concentrate on the one problem here. This has to do with pressures. Okay, the one we were just talking about was concentrations. Okay, so we look here and we see the equation, and the stress was to decrease the volume. This is VOL. It's a little hard to read, but that's VOL. And what we did when we decreased the volume, that increases pressure according to Boyle's law, because pressure and volume are inverse. So if pressure goes up, then LeChat wants to take the pressure down, and that's what he's going to do right here. And going down, the down arrow means opposite, and the opposite is opposite of more pressure. Which side of the reaction has more pressure? We added up the moles by looking at the 2 and the 1, and those are the coefficients. That adds up to the 3. And we looked on the right side, and the coefficient there was the 2 in front of the SO3, and that's 2 moles. So to bring the pressure down, we want to go to the side with less moles. And so the opposite side of the more moles is the less moles, and that's the right side in this equation, because 2 is less than 3. And that's how LeChat works in a thumbnail, quickie little shot of a few problems. All right, what we're going to do is refresh this. Or actually, we don't need to refresh it. We're just going to go straight on. Your reaction is given to you right here. Okay, that reaction is iron thiocyanate, this guy, is going to be broken up into iron and thiocyanate ion. And there is an equilibrium in this, which is reached, and then we're going to stress the system. So let's get rid of these marks, and let's go ahead and stress the system. I'm going to add NaSCN. Is that anywhere in here? You see that in the reactant products? You see NaSCN? What do you see? What part of that do you see? I see an SCN. Aha! Where is SCN? Right there. Okay, so if I'm adding NaSCN, I am in effect putting in the SCN ion. Okay, so that's what I'm doing for this stress. Okay, whoops. Did I get rid of it altogether? Thank you. There we go. We're started back up again. Now, I'm going to add the SCN, which is over here on the far right in the equation. And since I added this, what does LeChat want to do? He wants to remove it. Is removing the same or opposite side? Opposite. So that means we're going to see this line right here is going to go up. What's going to happen to these other two lines? These two guys are going to do what? They're going to go down. Absolutely. Okay, so let's go ahead and watch what happens as we do it. Momentarily, this guy, the SCN, momentarily will go up because that's our addition. We're doing that from the outside. And let's watch it happen. There we go. And let's go back. Here we go. We'll start it. Now watch it happen. See? The SCN went up. Now the shot's reacting. There it goes. There it goes. The shot reacted, and this guy went up. This guy went up. This guy initially went up, and then as the shot did his thing, it went back down. Not all the way, but some. See, LeChat is totally frustrated because whatever you do, he cannot undo it completely. He can never undo it completely, but he sure gives it a try. And that's what you just saw happen there. Now, let's go ahead and get rid of this layer. All right. Now, I'm going to do that concentration thing again. This time, I'm going to remove iron. So, this line is going to do what? It's going to drop. After it drops, LeChat wants to make it go back up, right? The first arrow is what we did. LeChat wants to make it go up. All right, so how's it going to do that? Same or opposite? Same. Okay, so the shift is going to be which way, left or right? Right, and what are we going to see happen with this one? He's going to go down. This guy will come back up some, not to where he was. See, he's at 4 right now. What's going to happen to this guy right here? He's going up, right? So let's go ahead and watch it happen. Yeah. Okay, remove the iron. Here it goes. There goes the iron. Almost all of it. Woo! Come back in. Come back. And look what happened to the color. Were you watching the color? Let's do that again. Watch the color. Okay, it's dark right now. More of this will make this guy darker, right? So I'm going to remove iron, and when I remove iron, we're going to take that FESCN, and it will get more to the color of iron, and of course SCN has no color. So here we go, remove the iron. Now watch the color change. See it? Okay, that color lightened up as the SCN moved up and the iron moved up, and the iron thiocyanate from the left side, that, what is that, reddish brown? Yeah, reddish brown. Okay, that reddish brown is going down, which is why that beaker got a lighter color, and you'll also see the lighter color up in this area. So both of these guys are showing you what's going on. There's a lot going on here. It's hard for your eye to see everything the first time, and those of you at home watching this, you'll probably want to replay this several times so you can get a real feel for what went on. Okay, that was how we did changes in concentration. Now we're going to deal with changes in pressure. For this, you have to know about Boyle's law. P1 V1 equals P2 V2. And Boyle's law states that because of this horizontal relationship here, that those guys are inversely proportional. So as pressure goes up, volume goes down. Or, I said it backwards. As pressure goes down, volume will go up. When pressure goes up, volume will go down. And that is what we're going to see happen here, and LeChatelier is responsible for that. So let's increase the pressure. How are we going to increase the pressure here? The external stress is going to be to add more pressure. How am I going to add more pressure? What do I do to the cylinder here? Shove it down. Okay, shove it down. It's like squeezing a balloon, and it'll make more pressure in there. Now, which side of this equation has more moles?
The right.
The right side. Yeah, you can see a 2 by the I, the single iodine on the right side of the equation right here. You see that that's a 2, and the coefficient here is a 1. There's nothing in front of it, so we assume it to be 1. And now we're going to go in, and let's see. I am about to increase the pressure, so that volume has to come down. Watch it go down, and watch what happens to the color solution. What's your expectation? How is LeChat going to make more pressure, or less pressure? Which side does he go to for less pressure? The left. Okay, when he goes to the left, what color is the guy on the left? Purple. What's going to happen to the color of the container that you're looking at over here? It's going to get darker. Indeed it will. Okay, let's go ahead and stress it. Increase pressure. Shove that baby down. And as you expected, it went darker. Oh no, it went lighter. Oh my goodness, how did that happen? Okay, let's watch what happens. It's going to react in just a minute. There we go. Okay. Did you see what happened there? LeChat's reaction was to make more of the I2, which is what we predicted. Pretty cool, huh? Shift left. Now, I'm going to decrease the pressure. What do I have to do that? Okay, so we're going to pull the plunger up, right? And where is there going to be a source for more gas, left or right side? So we're going to see a right shift. If we right shift, what's the color going to do?
Lighter.
It's going to go lighter. Let's try it. Here we go. Decrease the pressure. Increase the volume. Okay. And now it waits just a little bit, and you're going to see a shift. Oh, it waits a long time. Come on, baby. There's a narration that goes with this that is way confusing. Okay, there we go. There's LeChat doing his thing. See, we couldn't put any gas in from the outside. We couldn't take gas out. All we did was change the size of the container. Okay, so that's the change in pressure. And the last one is temperature. And you saw this in the video. So those of you at home now are going to be able to see this, only you can't see the video, but you will see a reenactment of it, of the N2O2, this stuff right here, which is colorless, and the NO2, which is brown. So the brown side is over here, and the clear side is over here. And it never goes completely clear, it never goes completely brown, because it doesn't go all the way either to the left or to the right. So let's go ahead and run the stress, and let's see how that works. Increased temperature. Watch this. This is so cool. They have a little temperature. They have a little Bunsen burner in here. We'll watch it go. There it is. See that little guy? Isn't that cute? Okay. What side is the heat on? Do you remember? Well, you're going to figure that out real quick, aren't you? Okay, remember we've got the N2O4. Yeah, the heat's on the left. Okay, and how do we know that for sure? The heat is on the left because we added heat, and LeChat wants to take the heat away. So the heat is sitting over here on the left side. And when we add heat to the left side, LeChat wants to take heat away, right? And the way he takes heat away is by shifting to the brown side, which is why that container got darker. And you may want to run your video back and look at that again and watch that happen. Now, for another change, let's go back, and now let's decrease temperature. What's your expectation? Since heat's on the left, okay, temperature is down. LeChat wants to add heat, and the only way he can add heat is to shift it to the left, which will make it go what? Lighter or darker? Lighter. Okay, let's go ahead and decrease the temp. Oh, look, ice cubes. Isn't that cute? Oh, darling. Right? Now it's going to take a little while to do it because the narrator on the regular thing is going to be talking his little head off. Ah, there we go. Finally, we're seeing it happen. Okay, boy, it got a lot lighter, didn't it? And that you have seen the 3 different stresses that can happen in equilibria conditions.